Welcome to the first video on the free and open source GODOT game engine platformer series. In this video, we will start to take a look at the building blocks of creating a platformer game for the engine. To make it easier to understand the main difference between the different engines that we are covering, we have thought of implementing the same game with the resources in different game engines. Since in GDevelop we have already started to put the foundations on a new platformer for the Melee tutorials, we have decided to use it too in default, GODOT, Construct 3, and Unity. In this tutorial, we will import all the assets for the level, player, and enemies. We will create a first draft level, and implement a basic movement that will allow us to control our player character. Let's dive into GODOT. First thing, let's create an empty project and name it. We are naming ours GODOT 2D Tutorial. Select the folder where you want your project to be saved. You can leave the project options with the defaults and click on Create and Edit Project. You are taken to the GODOT engine default view, which is always set to 3D. Let's set it to 2D by clicking on the 2D button on the top central bar. The central viewport changes from the 3D view to a standard orthographic view best suited for 2D games. In the left pane, we are asked to create a root node for a different type of project. We are going to go with the 2D scene. The left pane changes to display the hierarchy of the project, which at this moment, only includes a 2D node. Let's right-click on it, and let's rename it to Game. Once done, let's continue creating the level with a tilemap, as we have done in the other tutorials. For that, right-click on the root node and select the option Add Child Node. In the search box type Tilemap, and then select the Tilemap option. We can see that the tilemap object is now displayed on the hierarchy, and on the opposite side, in the inspector, we have all the options associated with the configuration of the object. The tileset that we are using for the level is 16 by 16 pixels. So, let's make the modifications to the tilemap properties. In the Cell tab, change the sizes X and Y to 16. In the Custom Transform, change the X and Y from 64 to 16. Once done, we are ready to import the tileset. In the Project Explorer, on the bottom left, right-click and select the option Add Folder. We are going to name it Resources. Next, go to the folder where you have your level tileset and drag it into GODOT. The system will import the tileset. Before we can use it, we need to make some changes to the way it was imported. On the left pane, over the hierarchy, click on the tab Import, and then on the new view, click on the button Preset. Select the option 2D Pixel, and then click on the button Re-import. The tileset will be re-imported with a pixel-perfect configuration. Now, let's prepare our tilemap to be used to create the level. In the right pane, under the inspector, you can see that we have a field named Tileset that is currently set to empty. Click on it, and then on the option New Tileset. The text will change from empty to the tileset. Click on it and GODOT will take you to the tilemap interface, which you can see below the main scene window. The first thing that we need to do is to bring the tileset into the tool. Drag it from the Project Explorer and drop it into the empty area on the left side of the tilemap editor. You can zoom into it with the buttons located above the main areas of the tool. To be able to use a tilemap in the game, we need to define tiles. To create them we have two main options. The first one is to manually create the tile based on selecting with the mouse the area of the tileset that we want to be incorporated. The second option is the auto tile, which allows us to define a series of patterns that are used by Godot to identify for each tile the different neighbors that it can have. Since we want to showcase the different workflows for each of the engines, let's use both of them. Let's start with the individual tile. Click on the option New Tile. Nothing changes, because you have first to select the areas that you want to be used as tile by clicking and dragging the mouse. As we move the mouse, we can see that the selection is not perfect and that the system is selecting areas that are bigger than 16 by 16. We need to customize it. With the Tilemap object selected, in the right pane, click on the option Snap Options and select Tiles and modify the configuration relative to the step that is listed as 32 by 16 by 16. Click on the selected tile option, and then click on the elements of the tile set that you want to see as part of the images to be used in the game. Make sure you have the Snap button enabled to have Godot help you to snap to each tile. You can see that we are not selecting individual 16 by 16 pixels tiles, but rather a large area that has multiple smaller tiles. Since these elements are not to collide with anything, we don't have to do anything else. Now, let's create the auto title. The auto title allows us to paint directly the level without having to choose individual tiles, as it is Godot's tilemap system that will automatically choose the tiles to be used depending on the patterns of neighbors. So, now that we have the auto title created, let's choose the area of tiles that we want to use. In our case, we will be creating the ground for our level with the 3 tiles of wood. Since it is where the characters will stand, we need to add a collider to it. For that, above the tile editor, next to the region button, you can see a button named Collision. Click on it. A new toolbar appears below with a couple of different options, like adding a shape, a polygon, delete or snap options. Click on the rectangle shape and then drag the cursor on top of the first tile of the ground. The tile turns blue. Click again on the rectangle shape and drag the cursor on top of the second cell. Repeat the same actions for the last tile. The 3 tiles should now be highlighted in blue. We can disable it if we want from the options, but it is easy this way to see that we have defined the collisions. Next, we need to create the auto tiling pattern that will allow Godot to know which tile to use depending on the level being drawn. Click on the button Bitmask. We could do this step in 2 by 2 cells, but it is easier to place them in 3 by 3, so in the right pane, under the selected tile option, look for the drop-down UI named Auto Tile Bitmask and select the option 3 by 3 Minimal. Now, zoom into your tile set until you can see the tiles. Click in the middle of the 3 tiles to create a line of red squares. This will indicate the auto title system which tiles to use when painting the tiles. The last tile to the right has a longer bitmask. Once finished, in the hierarchy, click on the Tilemap. To the right of the scene view, you can see now the palettes of tiles that we have just defined. Click on any of them and start painting your level. To keep each tutorial at the same level, we will be drawing the same early stage level with just one platform. Let's save the scene. Before running the game, let's check where our level from the camera point of view. If we zoom out, you can see that the camera view is represented by a blue rectangle on the scene view. Our level is almost outside of the level. Let's move it toward the center of the camera view. Let's quick run the game. The platform is there in the middle of the screen. Let's now implement the player. In the hierarchy, right-click on the root node, and from the menu select the option Add Child Node. In the search box, type Kinematic Body 2D and click on Create. Rename the new object to Player. Repeat the process to add an animated sprite, a collision shape 2D, and a camera 2D to have the camera focused on the player. Let's configure now each of the nodes added, starting with animated sprite, which will allow us to see our player and animate it smoothly. Select the animated sprite node and in the inspector click on the frames drop-down element that currently displays an empty tag, and select the option New Sprite Frames. Click a second time on the drop-down to open the UI associated with making the animations. As with the previous tilemap, as soon as you click on it, the area below the scene view changes to display the actions associated with the animation of sprites. Let's implement the idle animation for now. The first thing that we need to do is to import the sprites for the idle. So, go to the Windows Explorer, select the idle sprites, and drag them to the Project Explorer, into the Resources folder. Let's organize it by creating a new folder named Player and move the sprites there. Re-import them as 2D pixel from the Import menu. In the animation interface, select the default animation, right-click on it and rename it to idle. Below it, change the frames per second of the animation, from 5 to 12. Keep the loop option activated as we are dealing with a cycle animation. To select the actual sprites for the animation, you can go either through selecting the idle animations in the Project Explorer and drag them into the Animations Frames box, or by clicking on the Open option below the animation frame title and then from there locate the sprites in the project. In this case, we have gone through the second option to showcase different ways to work with Godot. Zoom in the scene view until you see the player sprite. You can see that there is no animation being played. If you want to see the animation running and want the animation to be run by default, then, in the inspector, click on the checkbox Playing. And now the animation for the idle is being played. Let's go now to implement the collisions. In the hierarchy, click on the collision shape 2D. In the inspector, in the shape drop-down UI element, click and select the shape that suits best your character. In our case, we are going to select the capsule 2D. The collider can now be seen in the scene view. For now, it is somewhat big. We can resize it by using the two handles in the collider that control the height and width. Adjust the collider to fit correctly our character. Let's go now to the camera. In reality, we could have started with Godot default camera, but since our sprites are so small, we will need to adjust the viewport to the correct viewing size of the pixel art size, which makes it best to start immediately with a camera. Select the camera and to make sure that it is the camera to be used by default, in the inspector, click on the current checkbox. This will make the camera override any other camera that we could have in the scene. Let's adjust the zoom. This parameter works in the opposite way you would think, so to get the viewport closer to the character player, you have to use lower values. In our case, we will start with 0.4 for both X and Y. In the process mode, currently set to idle, we will change it to physics to make the camera follow the character more smoothly and based on physics. Then, on the smoothing option, click on the enabled option to turn it on. This will make the camera follow the character more smoothly based on the speed defined below. In the scene view, if you zoom out away from the player character, you will see that the bounding box showing the boundaries of the camera field of view is now located around the player. So, if we quick run our game, we will see only the player. Drag the player to the position where we have put our platform. Let's quick run again, and now we can see both the player and the platform. Let's start coding. Right-click on the player node and select the option Attach Script. We are going to use the GD script, but we could have used also visual scripting. We will probably make a video specifically on visual scripting with Godot. Click on Create to go to the script editor. Since we have attached the script to a kinematic body 2D, you can see, right at the beginning of the script, that our script is extended or inheriting from that class. Let's define quickly some constants that we will be using in the code. To declare a constant, we will use the reserved keyword const. During pre-compilation, the reference to the constant will be replaced by the value we are defining below. A vector 2 to indicate which way is up. A gravity of 50 and max speed of 52. Let's add a max gravity, that will be used to cap the gravity intensity, of 100. And finally, a jump speed of 500. Next, let's define some global variables that we will be using to control the player. The first one, a movement vector, will keep track of the direction where the player is moving to. We don't need to initialize anything, so we can skip the ready function. So, if we need to move our character, once per frame, we need to perform the calculation to read the inputs and then make the movement calculations. Godot, like other game engines, has different functions that are called once or more frames per second. In our case, we are going to use the physics process function, which takes an input parameter, the delta time between frames. The Godot scripting language has some influences from Python, and some of the syntaxes used are similar to Python. For example, you can see that the system has automatically added a colon at the end of the line. If you press enter, the cursor will move to the next line, slightly indented to the right. This is the way GD script holds the structure of your code. Every line of code with the same level of indented is at the same level of execution. Every more indented to the right belongs to the statement above with a lower indentation. Let's write our first level of scripting by check the input of a key, if equal to left, then we will execute the instructions that will get the character moving to the left. As for the function name, we will be putting a colon at the end of the line. So, if we have pressed the left key, then we want to move to the left, and we need to apply a negative max speed to the movement, and since we are only moving right or left, to the X. If it is not the case, then we will use the instruction elif to check on the other condition of having pressed the right button, in which case we will use the positive value of max speed to move to the right. If not, then no keys have been pressed and let's set the movement to 0 on the x-axis. Let's implement the jump. First thing is to check if the character's player in the ground. Godot has an included method to do this. Check this fact. Is on the floor, will turn true if the collider bottom is colliding against any other collider. If grounded and if we have pressed the jump key, then the component y of the movement will be set to minus jump speed. Afterward, out of any condition, let's make the y movement to be updated with the value of gravity and check if it is bigger than the gravity, in which case it will be set to max gravity value. Finally, let's use the movement to move the player as effectively as possible through the method move_and_slide that takes as input the movement vector and the vertical up definition as a reference. Before running the game, we need to register the action maps that we have defined the inputs left, right, and jump. For that, go to the menu option Project, then Project Setting. Click on the tab Input Map. In the field Action, type the name of the action that you need, then press the Add button at the end of the line. Let's add the actions left, right, and jump. Then click on each of the actions created, and then in the add sign at the end of the line, GODOT will ask you to choose the key that we want to map. Repeat the process for each of the keys that have been used in the game. Let's quick run the game. And you can see that we are able to move our player through the platform but without the main animations. Let's quickly add them. Click on the animated sprite in the hierarchy and then on the animations button. Click the add animation and add the walk, attack, and hit animations. Select the different sprites for each of the animations and add them to the system. Don't forget to re-import as Pixel 2D. Be sure to check also the frame rate and the loop condition. Now, let's add the animations to the script, as to call them when needed. We are going to need to access the animated sprite node to access which animation to play. In GODOT, this can be done in two different ways. The first one would be to specifically get the reference to the node through getting_node, the second is a simplification implemented by GODOT and that makes the child nodes directly accessible if using the $type of node to be accessed. So, in our case $animated sprite followed by the method that we want to invoke. In the two checks for left or right, we will play the walk animation. In both left and right, we will also take advantage of pre-running the functions as we can flip horizontally the sprite as to be looking in the direction of the moment. If movement x is equal to 0, then let's play the idle animation. Let's quick run the game. And, we can walk and jump nicely. In the next episode, we will be integrating the animations and the first enemy. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.